Good morning, ladies and gentlemen. This is NU Pen from Material and Chemical Research Laboratories of Industrial Technology Research Institute in Taiwan. I'm glad here today to have introduced to our innovative ECO-redesign PV modules. In today's talk, the overview right here. First, I will talk about the need of the next generation PV modules, and then we'll introduce each PV innovations for two aspects. One is from the technical aspect, and the second we'll talk about from the economic value and the carbon emission aspect. And first, the need of the next generation PV modules. We can see from this map from the forecast, the PV installation capacities from 2018 to 2015 is grow rapidly. You can see even in the Asia, North America, and Europe, the installation is almost like 8 times or 10 times increasing. That's because we all face the challenge with the climate change and the net zero emission by 2050. So to build the clean renewable energy is required to replacement of the polluting powers. So from IRENA's estimate, the solar power generations will reach 8,519 gigawatts in 2050. However, the growing PV installation will bring another environmental issues. That is the growing PV waste. The lifespans for the PV modules are 20 to 25 years, and the demand of the replacement is high due to the tech development progress. So from these figures, in 2030, it forecasts, you can see the PV waste will become 8 million tons. And when it comes to 2050, the PV waste will become to 78 million tons. That was like 10 times of growing. What we need is a next generation solar module design. It should be easy dismantleable and full recoverable. However, the existing PV modules is lack of efficient solution and of the recycling. The recycling process is like to cause the solar cell fragment. And the most valuable components of the PV modules, like silicon and silver, could not effectively extract and recycled. This is the biggest problem. So therefore, there is the need to redesign the PV modules with higher recycle value and lower the carbon emissions in the production value chains. Next, we'll talk about the PV innovation from the technical aspect. The E3 has developed the renewable PV technology. This is a solar module innovation for fully recycled PV modules. And we can see from the commercial PV modules, the encapsulation of these modules is a thermoset material, it's like EVA. And this material is it's difficult to disassembling and difficult to recycle and also for reuse. And E3's redesign is an innovative thermoset and thermoplastic bilayer sealing structures. And it's combining the advantage of these two materials because the thermoset material is good for the durability, but it's hard to dismantling. The thermoplastic material is good for dismantling, but it's not for the durability. So E3's redesigned this bilayer film to make the PV modules dismantleable. And the commercial PV modules, because due to its encapsulation, its EVA is tightly to adhesive with the backsheet and the glasses, so it cannot recover the complete solar cells. And during the dismantling process, the materials will generate the gas, and this gas will become the gas bubble and have the pressure difference onto the solar cell. So it will lead to the solar cell cracking. Each bilayer redesigned sealing structures can recycle the complete solar cells. Yeah, this is because the thermoplastic layer it will firstly soften during the dismantling process. And when it softens, it can become a buffer layer to protect the solar cells. So we can obtain the complete recyclable solar cell, and this solar cell can reclaim silicon wafer for another renewed PV modules to use. And the bilayer redesign encapsule structure for the renewable PV modules technologies is reliable and high efficiency and recyclability. It should optimize the material rheology and the melting point, and also for the thickness of both materials for the best solution to protect the solar cell from cracking. We use the thermoset of EVA layer to provide a good adhesion to glass and the backsheet. And the bonding strength between the EVA and the TPE2 materials, the interface is strong. And optimizing the thickness to prevent the TPE from flowing and the creeping. And this the bilayer encapsulates film with a very high transparency. So the current average efficiency for this module is around 20 to 23%. So it's based on the solar cells. And the properties of the bilayer redesign encapsule film is at these tables. We can see it's with a very high total transmittance, is about 90%, and it's good at the module resistivity, and also good with water resistance. And what's more, it's easy dismantleable. And each is world's first easy dismantleable PV modules. These PV modules can obtain the complete solar cells, and this solar cell can reclaim into the high purity silicon wafers. Also, we can obtain the complete glass panels, and what's more, we can also have obtained the higher purity silver. Each ECO-redesign PV modules has met the IEC standards, the IEC 61215 and the IEC 61730, and was certified by two Highlands in October 22nd. It means this modules is ready to the market. So we are very great for these modules with the high efficiency and the durability and the recyclability. Next, we'll talk about the PV innovation from economic value and the carbon emissions. And this renewable PV technology increase the environmental values on two aspects. One is the recycling rate. The recycling rate of these modules is up to 96%. And the second, the reduction of the carbon dioxide emissions is about 400,000 tons per gigawatt. So it's about 15 to 55% off than the current PV waste treatments. The recycling for the current PV waste is dominated by the process of crushing and sorting. And the value of the recycling material is significantly underestimated. And each renewable PV technology can recover the materials is worth about 75 million euros per gigawatt, which is about 4 to 5 times higher value than the current treatment. We can see from these figures, from the silicon and silver, also the gas and the others, the each is also better than the current treatment. And we are talk about the full recycling system of these ECO-redesign PV modules. First, we'll remove the frame and the junction box. Then go to remove the backsheet. Then these modules will go into the thermal decompositions. Because due to our bilayer designs, the thermoplastic layer will become softened, a buffer layer to protect the solar cells from cracking. So can obtain the solar cells intact. So this solar cell can be renewed to the silicon wafers, and this silicon wafer can also go into the regenerate the solar cells for the next modules to be used. And also because due to the solar cell intact, so we can obtain the high purity silver wires, and also can get the complete glass panel, and also for the ribbons. And we compare about the recycling products from these two PV modules. The commercial PV modules, the approach is the crushing and the sorting. And the products obtain the low purity glass pellet and the low purity mixture. This can only be used to landfill or the constructional materials used. And for the silver, because due to the high cost, it's not recycling. And each ECO-redesign PV modules, the approach is by the pyrolysis and the chemical process. And this we can obtain the complete glass panel. And this glass panel can use be reused to glass product or renewable PV modules. And for the silicon wafers, we can get a reclaimed solar cell and for use for the renewable PV modules. And also for the high purity silver. And now we are talking about the carbon footprint reduction for these modules. The eTree's renewable PV technology is cycling modules from PV to PV. And in these production chains, we can see from silicon sack to polysilicon and the silicon wafer and for the solar cells. And going to the commercial PV modules, and it's a traditional crash treatment. And for the easy dismantling PV modules, it can go to the recycle process and can get a silicon wafer, and this silver can be reused to the reclaimed silicon wafers. And in this process, the most carbon emission part is from silicon sack to silicon wafer. It's about 212 kilogram carbon emissions. Yeah, this is almost about 44% of the carbon emissions. And for the renewable PV technologies, because due to the silicon wafer could be reused, so can have a 15 to 55% lower than the current solar PV modules. At the end, I'll make a short conclusion for today's talk. And eTree's innovation PV modules are environmentally sustainable products with many benefits to the society. And its circular design from PV to PV can reduce the carbon dioxide emission estimate by 50% off, and it having the lower environmental impacts of the product life cycle. And third, the eTree's innovations give a new life for the retiring PV modules and create a revenue and provide a win-win situation to both the economy and the environment. And this renewable PV technology and the recycling and the carbon dioxide reduction benefit. This tool is what we need for the next generation PV modules. Thank you for your listening.